Write the following as an exponential expression. So we're changing it from radical form to an exponential expression. So to do so, all we do is follow this. Our base is 6. The power in which it's being raised is our numerator. And the index, in this case 8, would be our denominator. So next we're going to do operations with exponential exponents. So in the first, we have x to the 4/7 times x to the 1/2. Remember, anytime you're multiplying like bases, what we do is add the exponents. So we're adding 4/7 to 1/2. So in order to add these, we need a common denominator, which is 14. So we need to multiply 7 by 2 to give us 14. Whatever we do to the denominator, we do to the numerator as well. So this would give us 8 over 14 plus, we need to change 1/2 to have a denominator of 14 as well. So we're going to multiply that denominator and numerator by 7. So this would give us 7 over 14. So when we add 8 over 14 to 7 over 14, we get 15 over 14, which would be our exponent. So our answer would be x raised to the 15 over 14th power. Our next problem, we have x to the 2/7 over x to the 1/2. So we're going to use the quotient rule. So whenever we're dividing like bases, we subtract the exponents. So we have 2/7 minus 1/2. So again, we need a common denominator, and it would be 14. So we multiply numerator and denominator of the first by 2, and numerator and denominator of the second by 7. So here we have 2 times 2, which is 4, over 7 times 2, which is 14, minus 1 times 7 is 7, and 2 times 7 is 14. So now we have 4/14 minus 7/14, which is -3 over 14. So we have x raised to the -3 over 14. The instructions say write using only a positive exponent. So remember, a negative exponent tells us to take the reciprocal. So x to the -3/14 will be rewritten as 1 over x to the positive 3/14. Our next question, we're going to be using the power rule. So the power rule states that whenever we raise a power to a power, we multiply their exponents. So we have v to the 9/4 raised to the 10 over 7 power. So we're going to multiply 9/4 times 10 over 7. Now we can reduce first. So 2 goes into 4 and 10, so we divide a 2 out. So 4 divided by 2 is 2, and 10 divided by 2 is 5. Remember that when you're multiplying fractions, you do not need a common denominator. So we're going to multiply straight across. So 9 times 5 is 45, and 2 times 7 is 14. So our answer would be v raised to the 45 over 14th power. Our next question is to simplify the square root of 75. So there's a couple of different ways to do it. So one way is to find the highest perfect square factor of 75, which is 25, and rewrite the square root of 75 as the square root of 25 times the square root of 3, since 25 times 3 gives us 75. Now we'll simplify. Since 25 is a perfect square, the square root of 25 is 5, and square root of 3 cannot be simplified, so our answer would be 5 square roots of 3. So our next problem, we're dealing with the square root of 108. So again, what we're going to try to do is find the highest perfect square factor of 108, which is 36. So we're going to rewrite it as the square root of 36 times the square root of 3. And again, since 36 is a perfect square, and 36 times 3 gives us 108. So now we simplify. The square root of 36 is 6, and the square root of 3 cannot be simplified, so our answer would be 6 square roots of 3. Next, we're asked to simplify the square root of 18, w to the 14th power. So one method we can do is do similar to what we just did in the past few examples, is to rewrite it as perfect squares first. So the highest perfect square of 18 is 9, and w to the 14th is a perfect square since 14 is an even number. And in my second radical, I'm going to write the other factor, which in this case is 2, since 9 times 2 gives me 18. So in the first radical, I have perfect squares. In the second radical, no perfect squares left. It would just be what would be left over. So now we simplify. So the square root of 9 is 3. And remember, when we were solving or simplifying an exponent, we divided the exponent by 2 when we were dealing with square roots. So 14 divided by 2 is 7. So we have 3w to the 7th on the outside of the radical, and we have 2 on the inside. So our answer would be 3w squared to the 7th, times the square root of 2. So our next problem, we're going to tackle it the same way. So we're going to write two different radicals, the first one being the perfect square since we're dealing with square root, and the other would be what's left over. So here we're asked to simplify the square root of u to the 21st power. So what we're going to do is rewrite it as the square root of u to the 20th, because we want the exponent to be an even number, and what's left over. So we have 20 of the 21, so we still have u to the first left in the second radical. So in order to simplify, since we're dealing with square root, we divide our exponent by 2, and 20 divided by 2 is 10, so that gives us u to the 10th power. And remember, the second one is already simplified, so our answer would be u to the 10th times the square root of u to the first, or just the square root of u. So our next problem asks us to simplify the square root of 25 u to the 7th. So we rewrite this as the square root of 25 u to an even power, which in this case would be the sixth, times the square root of u to the first. Because we had 7 u's, we have 6 and another 1, which gives us the 7. So again, in our first radical, it's a perfect square. So everything will come out from underneath the radical sign. So the square root of 25 is 5. And remember, in exponential form, we're going to divide the exponent by 2 since this is square root. So 6 divided by 2 is 3. So we have 5u to the third power. And underneath our radical, we still have u to the first. So our answer would be 5u cubed times the square root of u. So our next problem, we're asked to simplify the square root of 45 t to the fourth u to the third. So we're going to first find the perfect squares. So the highest perfect square factor of 45 is 9. Since we have t to the fourth, since that's even, we just leave it as t to the fourth. And u to the third, we're going to make the perfect square factor even, of course, so it'd be u squared. So in our first radical, made up of only perfect squares, we have 9, t to the fourth, and u to the second. And our second radical would be 5, because 9 times 5 gives us 45. We've already used up all the t's, but we use 2 of the 3 t's, so we have 1 u left. So next we simplify. The square root of 9 is 3. And remember, for our exponents, since we're dealing with square root, we're dividing by 2. So 4 divided by 2 gives us t to the second power. 2 divided by 2 is 1, so that would give us u, or u to the first power. And remember, the second radical doesn't change. So our answer would be 3t squared u, or u to the first, times the square root of 5u. So our next problem says write the following in simplified radical form, and now we're dealing with a different root. We're not dealing with square roots. So we're going to go and try a different approach using the same concepts though. So what I'd like for you to do is take the coefficient, which is 162, and break it down into a product of primes. So I start using my factoring tree. 162 divided by 2 is 81. 81 can be broken down into 3 times 27. 27 can be broken down into 3 times 9. And 9 can be broken down into 3 times 3. So what we have here is 2 to the first power times 3 to the fourth power, since we have 4 factors of 3. So 2 to the first times 3 to the fourth. So we're going to rewrite our problem as 2 to the first and 3 to the fourth. Now to simplify, our exponent has to be a multiple of 4. So it either has to be 4, 8, 12, 16, etc. So when I'm rewriting this as perfect fourth roots, I start by writing the fourth root of 3 to the fourth. Since the exponent is a multiple of 4, times the fourth root of 2 to the first. So remember, everything in the first will be able to be simplified by doing our division of exponents. So 4 this time goes into 4 one time. And then as far as our other factor, it cannot be simplified, so we write it as the fourth root of 2 to the first. Now, those exponent of 1s are not necessary, so our answer would be 3 times the fourth root of 2. So our next problem, we're asked to simplify the fifth root of v to the 12th. So again, when we're simplifying in our first radical, we want multiples of 5. So it can be a 5, it could be a 10, it could be a 15, etc. So we rewrite this as the fifth root of v to the 10th times the fifth root of v squared. So now we do our division. 5 goes into 10 two times, so we have v squared on the outside. And remember, the second one is already simplified, so that would be times the fifth root of v squared. Our next problem, we're asked to simplify the fourth root of 81 w to the 15th. So again, since it's not square root, we want to use our factoring tree to break down 81, 3 times 27, then 3 times 9, and then 3 times 3. So 81 is the same as 3 to the fourth power. So before we simplify, I want to rewrite this as the fourth root of 3 to the fourth times w to the 15th. Now remember, when we're simplifying, we want multiples of our index. So we can use a 4, we can use an 8, we can use a 12, etc. So in simplifying this, I have the fourth root of 3 to the fourth. Now for w, I'm going to use w to the 12th because that's the highest multiple of 4 closest to 15. Now in the second, I write what remains. I don't need any more 3's, but I use 12 of the 15 w's. So when I subtract, that means I have 3 left. Now in simplifying, we divide. So 4 goes into 4 one time. So I have 3 to the first. 4 goes into 12 3 times. So I have w to the third. And remember again, the second radical is already in its simplest form, w to the third. How do I know it's in the simplest form? Because my exponent, 3, is smaller than my index. 4 can't divide into 3. So my final answer would be 3 w to the third times the fourth root of w to the third. So our next one, we're asked to simplify the cube root of 125 x to the 17th w to the 13th. So again, we're going to start by breaking 125 down. So that's 5 times 25, and 25 can be broken down into 5 times 5. So 125 is 5 to the third power. So I'm rewriting my radical as the cube root of 5 to the third, x to the 17th, and w to the 13th. So remember, when we're breaking it down into perfect cubes, our exponent has to be a multiple of 3. 3, 6, 9, 12, 15, like you're counting by threes. So to simplify this, I have the cube root of 5 to the third times x to the 15th times w to the 12th. Notice 3, 15, and 12 can all be divided by 3. So in my second radical, I have the remaining factors. So I don't need any more 5s, but I need 2 more x's, so it equals 17 total. And I need 1 more w to equal 13 total. Now I simplify. So I'm dividing my index 3 into each one of my exponents in the first radical. So 3 goes into 3 one time. So that's how many 5s I have, 5 to the first. 3 goes into 15 5 times. So I have x to the 5th. And 3 goes into 12 4 times. So I have w to the 4th. And again, remember that my second radical is already in its simplified form. So I have the cube root of x squared w. Now I'm going to rewrite this. So my final answer is 5 x to the 5th w to the 4th times the cube root of x squared w.